This lesson is determine the dimension of null A and column A. Here we have a matrix, 3, 4, -6, 10. I'm going to rewrite this matrix down here, and we're going to do row operation. Our objective is to turn this matrix into 1, 0, 0, 1. Okay, so this 3 right here needs to be a 1. So we will multiply the reciprocal, which is 1/3. 1/3 times 3 will be 1. 1/3 times 4, which is 4/3. Next, we need this -6 to be a 0. So opposite of -6 will be +6. So 6 times row 1 plus row 2. So 6 times 1 is 6. 6 subtract 6 gives me this 0. 6 times 4 will be 24. 24 divided by 3 will give me 8. 8 plus 10 gives me 18. Next, we need this 18 to be a 1 over here. So multiply the reciprocal. So 1 over 18. 1 over 18 times 18 is 1. Next, we need this 4/3 to be a 0. So multiply the opposite of positive 4/3, which is -4/3. So -4/3 times row 2 plus row 1. So -4/3 times 1 is -4/3 plus 4/3 gives me 0. And now there's nothing to do. We are done. We have 1, 0, 0, 1. We are completely done. Next, this right here has a pivot position. This right here has a pivot position. So this matrix, the original matrix, has a dimension of column A, which is 2. One more time. Because it has a pivot position here, it has a pivot position here. So the dimension of column A is 2. One more time. There is a pivot position here and a pivot position here. Since there are 2 pivot positions, then the dimension of column A is 2. However, the dimension of null is 0 because none of these pivot position is 0. One more time. This is not a 0. This is not a 0. So the dimension of null A is 0. One more time. I have a pivot position. I have a pivot position. Since I have 2 pivot position, dimension of column A is 2. However, there is no 0 here. There is no 0 here. So the dimension of null A is 0. Okay. Next example. Same procedure. So here I have a 3 by 3 matrix and I wrote it down here. Now I have 1 here, I have 0 here, I have 0 here, so we are okay. We don't have to worry about it. Next, we need this pivot position to be a 1, so multiply 1/4 to it so I can get a 1. So multiply the reciprocal of 4, which is 1/4. So 1/4 times 4 gives me 1. 1/4 times 7, which is 7/4. Next, we need this to be a 1. So multiply the reciprocal of 1/5 so I can get a 1. So 1/5 times 5 is 1. Now if you look carefully, this right here, I need a 0. So opposite of -1 would be +1. So +1 times row 2 add to row 1. Okay, so 1 times 1 will give me 1. Subtract 1 gives me this 0. 1 times 7/4 is 7/4 plus 0 is 7/4. Okay. Next, we need this to be a 0. We need this to be a 0. Okay. So this column I have 1, 0, 0, 0, 1, 0. So we are okay with that. We just need this to be a 0. So opposite of positive, which will gives me negative, and do the same thing up here as well too. So 1 times negative 7/4 is negative 7/4, plus 7/4 gives me this 0. So that's for row 3 and row 2. Now we're going to do row 3 and row 1. So negative 7/4 times 1 is negative 7/4, plus 7/4 gives me this 0. Once I have 1, 0, 0, 0, 1, 0, 0, 0, 1, then we are completely done. No more row operation. Next, we need the dimension. Since I have a pivot positions, I have 3. 1, 2, 3. So dimension of column A is 3. Since this is not a 0, this is not a 0, this is not a 0, so dimension of node A is 0. One more time. If there is a pivot position, then that's how many the dimension is. If I have a 0, 0, 0, then that will tell you the dimension of node of A. Okay, so one more time. Here I have a pivot position. Since I have 3 pivot position, then the dimension of column A is 3. This is not a 0. This is not a 0. This is not a 0. So none of these are 0. So dimension of node A is 0. Next, the last example. Same procedure. Okay. So here is the original matrix, and I wrote it down here. I have 1, 0, 0, so we're good. So we leave that alone. This right here needs to be a 1, so multiply the reciprocal of 7, which is 1 over 7. So 1, 7 times 7 gives me 1, and then 1, 7 times 0 is just 0. However, if you notice something, up here I have a 4, so that needs to be a 0. So opposite of 4 will be negative 4. Okay, so negative 4 times 1, negative 4 plus 4 gives me this 0. Negative 4 times 0 is 0. 0 plus negative 1 gives me this negative 1. And as you can see, this right here has a pivot position. This has a pivot position. So I have 1, 2 pivot position. So the column A, dimension of column A is 2. However, I have a 0 here, so the dimension of node A is 1. So that's how you determine the dimension of column A and dimension of node A. Dimension of column A need a pivot position. Dimension node A need a 0 and in their pivot position. Again, if I have something in the pivot position, then that will be our dimension column. If I have a 0 in the pivot position, then that will be our dimension of node. So in this situations, I have 1, 2, so dimension of column A is 2. I have a 0 in here, 0 right here. 0 could be here as well too. It could be here, it could be here, or sometime it could be here too. So here, here, but if I have a 0 in any of these pivot position, and that will tell me how many, that will tell me the dimension of node A. Okay, so again, 1, 2, because I have something here. I have a 1 here, so the dimension of column A is 2. Here, this pivot position is 0, and I only have 1, 0, so the dimension of node A is 1.